Slope-intercept form is the most common equation form that we have for linear equations around. Slope-intercept form gets its name because of the components of the equation you have. You have a slope and you have an intercept point. Specifically, it's the y-intercept point. Before you can actually get to working with the slope-intercept form, you have to understand its biggest component, which is slope, and how slope works. So what we're going to do in this video is we are going to look specifically at slope, and we are going to look at all the different ways that we have at being able to find and calculate slope. So by definition, slope is the slant of a line. Okay, it is essentially the ratio of the change in your y value over the change in your x value. Most students should recognize it as rise over run. When we're trying to find slope, we have many different ways that we can attack the problem. The first is we could be given an ordered pair. Given an ordered pair uses what's called the slope formula. Change in y means y2 minus y1 over x2 minus x1. So if you look, y2 and x2, this right here would be your ordered pair. And then you have y1, x1, that would be your ordered pair. So essentially what you would be given is you would be given two coordinates of x1, y1, and then x2, y2. And so you use these two coordinates to come up with this equation here. So notice the order is very, very important. Now, another thing that you could be given is a graph. If you're given a graph, you're going to use your intercepts or your coordinate points in order to do it. So you either are plucking those directly off of the graph. Remember, you need 2 points because remember you have to have 2 points in order to find your slope. So in terms of a graph, you need to find 2 different coordinate points. Then you can go ahead and use your slope formula. Now, given an application, you would have to use the same methods that you would use using a graph, unless your application has an actual formula itself, and so those are going to be kind of more case-by-case basis. So with an application, you have to look specifically at what you've been given, and then use what you've been given. Now with that, we could be given an equation. And so if we're given an equation, there's a few things that must happen. First, your equation must be solved for the y value. Doing this is going to give you that slope-intercept form, which is what we want. Slope-intercept form is the form that states y equals mx plus b. And in this form, what's so important about it is that the m part, so this right here, is your slope. Now last we have your special lines. So special lines are just that. They are horizontal or vertical. What you have to remember is that horizontal lines have a slope of 0. Their equation comes from the form y equals something. Okay, what it means is that you are not changing your y value in any way. Now, vertical lines have a slope that is undefined, and the reason for that is because a vertical line has an equation where you have x equals, and you are not changing your x value. So if you look at your slope equation, to not change a y value puts the 0 on top, thus gives you a 0 overall. If you don't change your x value, that puts the 0 on the bottom, thus giving you a black hole, which means we're undefined, because you cannot have 0 on the bottom. Okay, that's just a fundamental rule of fractions. And overall, slope is inherently a fraction. So what we're going to do is we're going to look at a bunch of different examples so that you can see each of these different types of slope in action. So first we have find the slope, and notice I have these 2 points here. So what you have to do is you have to identify your x1 and y1 values first, and then you're simply going to plug into the formula. Now the trick that I like to use is with my negative. Here, because I have this -6, I would choose to make this x1 y1, which makes this x2 y2. The reason for that is this: when we use the formula, that formula says m is equal to x or y2 minus y1 over x2 minus x1. So when we plug it in, this would end up being 2 minus 3 all over 1 minus a -6. Now, what do we know? We know that minus a negative is the same as positive. So I can get rid of my negative sign and change it to a positive. So this here is going to give you 2 minus 3, which is a -1. 1 plus 6 is 7. So therefore my slope, so m, is a -1/7. And this is the answer we're looking for. Now we want to do the same thing, but notice here I have a fraction. So you got to be very careful with that fraction. So again, that fraction, at least for me, I would override a negative. So I would make this x2 y2, which makes this x1 y1. So again, we're going to set up our slope. So we have y2 minus y1, so 2 minus a half is all over x2, so -1 minus 4. Now, when we are looking at the top here, we need a lowest common denominator to subtract. This follows your fraction rules. Which are some of the most fundamental rules that we have. Okay? So here we have to do kind of a little bit of math before we finish out the rest of our slope. So first of all, I have 2 over 1 minus 1 over 2. Now remember, any whole number you have is inherently over 1, and so you can go ahead and solve this. So between 1 and 2, my least common denominator here is going to be a 2. I have to multiply this fraction over here by 2. 2 times 2 gives you 4 minus 1, so the whole thing is over 2. 4 minus 1 is 3, so this is going to be 3/2. So I can go back to my slope. So my slope is going to be 3/2 over, and then do the bottom. -1 minus 4 is a -5. Fraction rules say keep the top. So 3/2, change the sign, and flip the reciprocal of the other. So this is -1/5, which is going to give us -3 over 10. because your rules say you're going to go straight across the top and straight across the bottom. And since nothing simplifies here, then we're done. So my slope is -3/10. Now this next one says a road slants up 1.3 feet for every 100 feet. Find the grade of the road as a percent. So we're talking about a road slanting. So here I would kind of draw myself a little picture, and so what we actually have is a triangle here. And what we're telling you is that it's going up 1.3 feet, so this would be 1.3 for every 100 feet. So this is 100. Okay, so every 100 feet we're raising it another third. So if we were to extend this triangle out, we could go another 100 feet and we would have 1/3, or 1.3, 1.3, if that makes sense. So we want to find the grade of the road. Grade right here essentially means find the slope. So here the slope again is going to be your change in y. So the y value is going to be the 1.3 over your change in x, which is 100. So we want to go ahead and actually divide that out. So here you would find 0.013, and that would be your decimal. And then of course that's talking about your grade. Okay, so your decimal, of course, you could change it to a percent, which is very simple. You would multiply by 100%. And so that's what we're looking for, is just your slope. Now here we have x equals -3. So this is an x equals equation. This means that we have a vertical line. And vertical lines are our special case. Which means we have a slope of undefined. Okay, so remember, vertical lines, it's just automatically undefined. There's nothing else for you to show here because we're just looking, this is the definition. Now this last one here that I want to look at is a graph, and so what we have to do is we need to pick the points. The easiest thing to do is to look for places of which that you cross your axis line. Those are going to give you the fastest points to use. So here we're crossing our axis line on the y-axis. So we need to figure out 1, 2, 3, 4. So this point right here is crossing at the point 0, 4. On my x-axis we're at 1, 2. So this point here is crossing at the point -2, 0. So now we can find your slope by again doing y2 minus y1 over x2 minus x1. So here it doesn't matter. So we can do x1, y1, x2, y2. So this would give us 0 minus 4 all over -2 minus 0. 0 minus 4 is a -4 over a -2. Minus a negative becomes positive, and 4 over 2 becomes 2. So essentially what this tells us that we're doing is it tells us that we are doing a rise of 2 over a run of 1. And we can actually check that. So here, when you have a whole number, your slope of a whole number is the same thing as thinking about, say, 2 over 1. So if we were to start here at my intercept. My slope says I'm going to go up 2 over 1, and that should land firmly on your line. You can check it again, up 2 over 1, and it lands firmly on the line. So that's one way you can check and make sure that you identified the proper slope, and thus there it is. So in a nutshell, that's kind of everything that you need to know about working with slopes in all different forms. So if you have any questions, please be sure that you let me know. Otherwise, be sure to smile, relax, enjoy yourself, and as always, I'll see you next time.